Well, here we are, the last day of the OpenSIPS Summit 2020 distributed. That's right, folks. This is your last chance to get some amazing information into your
Just one
noggin.
correction, Alex. It's not the last day. It's the last day of the conference, because next week we're going to have 3 more days, part of the event. Monday, work, OpenSIPS. Tuesday, again, OpenSIPS and OpenSIPS training. And Wednesday, with a special occasion, a second class for the OpenSIPS training.
Wait, it's official? There's a second one?
Yes, we made the
When
poll.
were you going to tell us this?
Well, if you read the channel, it's over there. Yep.
So
yeah, so following yesterday poll, there were like at least 9 people saying yes, we would like to register. So we agreed to run a second class Wednesday, and just to get some nice balancing between the 2 classes, because in the first one we had like almost 28 people.
Wow.
We are like shifting some of, on free will, some of the students from Tuesday to Wednesday, just to get more or less to the same, amount of students per class.
Awesome. Awesome. So it's 10:04. Today we're going to be talking about Media Exchanger and OpenSIPS, and that's going to be Razvan Crainea that's going to be giving us a presentation on that. So without any further ado, one of the core developers at the OpenSIPS project, you all know him well. If you don't, then you've got issues. Razvan, are you here?
Sure. Thank you, Alex. I hope everybody will have already seen my presentations up until now, at least during this conference, and hopefully you like this one too. So let's get started. Let me start my presentation here.
While Razvan's getting started, I want to remind everybody that our YouTube channel does have a subscription to it, and you can catch past and present and future discussions with great speakers and knowledgeable people in the industry whenever you want, sitting on the couch. So don't forget to subscribe.
Yeah, just a quick mention on the channel. Sorry, Razvan, to bust in. Well, there is a plan. Well, sorry, that's it. There is a plan to put more vids over there. Not only like conference recordings, but also like kind of a small. I wouldn't call them training, but probably small demos on, especially on the new things that we will be doing. So be more and more information over there. So yeah, I should say that you should follow it. So Razvan.
Yes, please do subscribe. So let's get started. Today we will be talking about Media Exchanger in OpenSIPS, what we have done, how we decided to work with it, and so forth. Hopefully you'll find this a great tool as I've found it during development and during design. And you can find out, you can also tell us what other cool stuff you will be playing with it. So let's get started. Today we'll be talking about the Media Exchange module in OpenSIPS 3.1, the media forking part of it, and I will show you a few use cases to understand exactly how you can use it so you can enhance your calls with different audio and video scenarios. So on a higher level, let's say media exchange is a mechanism to to provide enhanced media, either audio or video, for proxy'ed calls. It can be used to easily scale media services and media servers because it is very lightweight. So having a call, you don't really need to pin it to a media server to provide enhanced media services. You only need to do that when you really need a special kind of service. If you simply need a call between 2 different endpoints, but some time in the future you probably need, for example, to play music on hold and so forth, you don't really need to engage it or to pin it to a media server. You can leave the call to be proxied between the two user agents and only engage the media server when needed. To do so, we used a couple of tricks to mix or swap SDP bodies between proxied calls. But the fun part is that you don't really need to have any special support from the user agents. Everything is already bound in them. All you need, so they're already SIP, the entire mixing and swapping the SDPs are already SIP compliant. You really don't need anything else but a valid SIP implementation. Let's see how all the entire idea started. So imagine that you have a proxy. You have 3 different devices. And for now, let's forget about SIP calls. Let's only think about how, like in theory, how RTP works. So whenever, let's say, Alice wants to talk to Bob, he's saying, hey, Bob, where should I talk to you? Right? And Bob will say, hey, Alice, you can reach me here at SDPB. SDPB is is Bob's SDP and contains the APN port where Bob can be reached, where Bob can receive the media. So whatever Alice has to say, it has to send it to that SDP IPN port. But Bob is not saying is not talking directly to Alice. He's using a proxy, let's say OpenSIPS. He's using a proxy, and whenever, although we normally are not allowed to do that as a proxy, you might want to say, hey, Alice, I think you should talk to Carol. Don't talk to Bob. He doesn't have that much to say. I want you to talk to Carol. Carol, how can Alice reach you? And Carol will say, hey, Alice, you can reach me at SDPC. Therefore, instead of providing, instead of providing the SDP of Bob, the proxy within the same call will send Carol's SDP. What would happen is that instead of talking to Bob, Alice will talk to Carol. Not sure if this resembles you with any mechanism, but more or less this is exactly how media works. So instead of having Carol here, what if we had a media relay, such as RTP proxy or RTP engine? The very same thing would happen. Alice will talk to the media server, Bob will talk to the media server with RTP proxy and so forth, but they will hear each other because the media relay will simply relay the RTP. Let's get a bit further and see what happens if Carol, let's say, is a media server. So imagine that we have a call from Alice to Bob, and everything starts like a regular SIP call. You don't really need to do anything, just relay invites from one part to the other. So Alice is calling Bob. It will provide Alice's SDP, that's SDP A, and OpenSIPS will say, hey, Bob, you should talk to A at SDP A. Bob will say, okay, I will do that. And if Alice wants to reach me, Alice will have to reach me at SDPB. And OpenSIPS will forward it further, saying, hey, Alice, you should talk to Bob at SDPB. Therefore, RTP will be established between Alice and Bob directly. We're not using an RTP relay at this point. They will talk to each other over the public internet or whatever. So we don't have this problem yet. But now at a certain moment in time, we from the proxy side, we decide to provide us to, let's say, playback something to Alice. So what OpenSIPS will do, it will send it will start another call. This is the blue call, let's call it. It will start another call saying to the media server saying, hey, this is my SDP. But if you notice, the SDP is A's SDP. The media server will answer the call, and in the 200 OK, it will send its own RTP. So it's the SDP of the media server. But now we'll be saying, hey, Alice, instead of talking to SDP B, you should talk to B at SDP MS. This will basically result in Alice talking to the media server. Not sure what I've done. Okay, this will result in Alice talking to the media server. So basically, this RTP flow will be between Alice and the media server. So Alice will have everything that the media server needs to hear, anything that media server sends to it. An interesting fact is that, as you can see, there's no one telling anything to Bob that anything. So Bob will continue sending RTP to Alice. So in order to, let's say, silence Bob, we will have to put it on hold. Otherwise, he will continue sending RTP to Alice. So basically, a common scenario of the media exchange would be when Alice and Bob establish a call, and during a call, a media service needs to be engaged. So in order to do that, we will eventually need to end up with an SDP that has to be sent to one of the parties, to either the caller or callee. And to do that, we are sending a re-invite within the initial dialog with providing the media SDP. The participant, as you've seen, will start sending RTP to the media SDP, and we will optionally put the participant on hold. I will tell you why optionally, but when I will show you a real scenario where putting the other participant on hold is not needed. Everything goes fine. So we had an initial call. We have another call starting to the media server. But let's say the media server, the media service ends. For example, you have to play an announcement. The announcement has terminated. So you want to pull out the media server from the path. All you have to do is send a call to the media server and re-invite both parties in order to learn or relearn the original SDPs. So how this would look like, we have here a call established between Alice and Bob. We have RTP between them. Now we want to originate a call from OpenSIPS. We will send an invite with a SDP in the media server. We will get back a 200 OK with the SDP of the media server. Send a re-invite to Alice. We will receive a 200 OK with A's SDP. Of course, this might change, so that might be a problem because when challenged Alice, this SDPA might change. Therefore, we should re-invite the media server saying, hey, Alice has changed its SDP. But let's keep the thing simple for now. Flow will go through this part, and a re-invite will be triggered from OpenSIPS to Bob saying, hey, SDPA is on hold now. So we will have to set the send only marker in the SDP. Right? So this is how it works when OpenSIPS originates the call to the media server. The other direction is also possible. Having a call established between Alice and Bob, and the media server initiates a call. Let's say from an external entity, we want to inject some media inside the call, and I will show you during the demo when we might need to do that. So the media server will send an invite containing the SDP of the media server, of course. Therefore, we will send a re-invite to Alice with the media server SDP. In the 200 OK, we'll get A's SDP, which will send to the media server, and the RTP will again flow from Alice to media server, but we still need to put Bob on hold in order to make sure that he won't send RTP to Alice. If he would, that might be a problem. So after we send the re-invite, this RTP flow will disappear. Basically, this is a scheme of how it works. So as I said earlier, in order to, there are two possible methods of providing a media SDP to the endpoint. once when the call is triggered by OpenSIPS. So a call is to the media server is started, and the reply is received from the media server is pushed through a re-invite in the initial dialog. And in order to do that, we need the back-to-back entities module, because he's the one that manages the second call, so the call to the media server. And this call can be either triggered through a script or through the back-to-back entities module.
Razvan,
Yes.
this is using the sequential reinvite or something like, okay.
Yes.
Okay,
It's exactly the sequential reinvite function, but internally using it.
I'm using this one. Okay, perfect. And is using the B2B module?
Yes, the B2B module is used for example, for this blue call, because as you can see in this call,
okay.
there's
It's only
one
underlying. I mean, you don't need to do the script for the XML. Okay.
No. So you don't use the back-to-back logic. So you don't
perfect.
you don't need to have
it's
any.
Like I do. Okay, I'm happy.
No, so we do need back-to-back because, as you can see here, there's no SIP endpoint to talk to the media server. So we create a virtual SIP entity using the B2B entities module. But that's only used for this call and only lives as long as this call is alive. As soon as the call is terminated and the SDPs get back to original, the call will continue to be proxied as a regular proxy call. So you will see it in the dialog table and so forth and so on. So it won't do anything with the B2B logic module. There's another, the second scenario that I presented is when the call is triggered by the media server. So we still need the B2B entities module to absorb the call. So again, we create a B2B SIP entity in order to a user agent server entity that will absorb the invite, will send it to 100OK, and will do all the SIP logic that has to be done by a B2B entity. In terms of requirements, as I insisted earlier, and I will say it again, there's no SIP extension. So this is part of the traditional SIP RFC. However, you'll still have to import some modules. For example, the dialog module, you need to get your you need to engage dialog for the module for the calls that you want to provide enhanced media services. That's because the dialog module has a lot of logic to store the SDPs and keep some state information about the call, about the status of the media, and so forth. But probably 99% of the calls that OpenSIPS routes are already using dialog module, so I wouldn't bother that much about this. The B2B entities module also is needed because, as I said, we needed to intercept calls from media server or originate calls to media server. But again, we don't really need the B2B logic that requires that ugly, let's say ugly XML file. It's just the entities. It's just the part that emulates the SIP endpoints. That's it. And of course, you will need a media server or another SIP entity, because it doesn't necessarily have to be a media server. It depends on the kind of services that you want to provide. But usually it would be a media server. But as I will show you later, you can also do it with a different handset like a hard phone. For example, okay. For example, if you want to do media forking. So the idea of media forking is more or less the same. So you have an SDP, what can you do with it? And we thought of why not, if we do have access to this SDP, how can we copy it? And in order to copy the media itself, you need to get access to the media flow. Luckily, we have different projects that allows us to, let's say, put OpenSIPS or put us in between media flow. So we have RTP proxy, RTP engine, media proxy that are all in the path of RTP. And then we thought, what if we ask the media relay to fork the RTP to a different destination? That would be nice, because that would basically be able to listen to an ongoing call. And we knew that RTP proxy does that. So we could use RTP proxy to fork the media to a different RTP, to a different SIP point. However, we didn't have the proper way to emulate that SIP endpoint, or to inform him that he needs to start a new call. That's why we added the B2B entities module on top of it in order to instruct a different SIP endpoint that we will be sending RTP to them. And I'll be frank, this is basically how the SIP-rec module works. So it's the same thing, except that you provide extra information about the call that is being recorded. But besides that, this is exactly how the SIP-rec module works. However, there are a couple of limitations between the two implementations. For example, using media forking, you can engage recording anytime during the call, while SIP-rec is only able to inject itself at the beginning of the call. You can't stop recording of a SIP-rec session, whereas you can stop forking of a media call, of a media forking. However, you don't have the entire metadata that is provided by SIP-rec. So it's a compromise depending on what exactly you need to use and what kind of services you want to offer. As a diagram, so here we have Alice, Bob, OpenSIPS, and RTP proxy. We have a regular call that is being proxied through RTP proxy. Alice will talk to RTP proxy through using this stream, RTP A to RTP media server B, and RTP B to RTP media server A. And at a certain point in time, Carol says, hey, I want to listen to Alice's conversation, let's say. What he will do, he will send an invite to OpenSIPS containing, hey, tell me what Alice is saying at SDPC. Of course, what OpenSIPS will do, it will instruct RTP proxy to say, hey, send RTP A to the IPM port that Carol provided, so to 4K RTP A to SDPC. RTP proxy will return, let's say, it will simply say, okay, I will do that. And we'll build an SDP based on that will send, we will send to Carol. At this point, the RTP proxy will start to sending RTP to C. Note that nor Alice nor Bob are informed about this. That's because everything happens in RTP proxy. RTP proxy has the entire RTP flow, so what he will do, it will simply copy it to a different destination. That's it. So the scenario is Alice and Bob establish a call. The call has to be proxied through RTP proxy, so if we don't have RTP proxy, we can't intercept the RTP, so we can't fork it. And at a certain point, somebody wants to listen to that conversation, so that user agent makes a call to OpenSIPS. It does work the other way around, so from whatever logic from your application, you decide that this call has somebody has to listen in this call. For example, in a call center scenario, where if you see some bad habits of one of the agents, you probably want to pop in that call and see how that agent behaves. So you can simply call in. OpenSIPS will instruct RTP proxy to forward the media, and the listening can be paused, can be resumed. So basically, you can do whatever you want with that call. You can even close and start a new one. So there's no particular limitation. In terms of limitation, basically, one of the big problem, actually it's not a problem, it's the way it's designed, right? So RTP will only be unidirectional from RTP proxy to the user endpoint. You will only be able to listen to what other participants talk, but you won't be able to talk. That's because RTP proxy, there's no logic to allow RTP proxy to inject that stream inside the call, at least not for now. You can listen to the conversation of both participants, but that might be a bit tricky. That's because RTP proxy is not doing any sort of media of RTP mixing between the two streams. So what you will end up, if you want to listen to both participants, you will end up with two SDP streams that you will have to mix it yourself. The fourth limitation comes from both OpenSIPS and RTP proxy, and we will probably need to work out a solution for that. An ongoing call can only have one single listener. That's because from RTP proxy is only able to fork to one single destination per call. Not sure if that has changed, Max, but we might probably need to talk about this. But as far as I know, there's no way of identifying a forking.
Yes, I think Razvan, you're right. Yeah, I can comment on this. Yes, there is no way to do it more than one fork now. I was thinking about moving that functionality into a module, which then would allow you to have pretty much as many forks as you want. But yeah.
Yeah, we need a way of matching them together, right? Because there won't be none at the SDP or SIP level. But yeah, we'll figure it out. But yeah, it comes from both OpenSIPS and RTP proxy, because on OpenSIPS side we can't manage multiple calls either for a single listener. So yeah, we need to work this out.
We're back to the x-call-id header.
Yeah, yeah, and that's exactly the question that Giovanni asked me like on Monday, right? Like 5 days ago. Yeah, unfortunately, it's not available now. However, I will show you a nice way that you can do this. But yeah, let's postpone it. Bear with me until the end of the presentation, please. And one last limitation is that you won't be able to do any codec negotiation because RTP proxy is not doing transcoding. So if you have a call between Alice and Bob and you want to listen Alice, let's say, you will have to use the codec that Alice uses in that initial call. So you won't be able, nobody will be able to do any transcoding. That's because Alice will send, let's say, G711 to Bob. RTP proxy will only be able to fork, to duplicate the codec that he received. So this is another limitation. Not sure how big it is, but up until now, if you're using like common codecs, everything should be okay. Okay, so let's move along to probably the things that most of you are interested in. How can I use this media exchange? How can I use this module? For example, as I've already showed you, you can listen in a call. So having a simple call that flows through RTP proxy, between Alice and Bob, RTP flows through RTP proxy. Carol will start a new call, will call in, will send a call to OpenSIPS, let's say, hey, listen, and send me the SDP to C, and the RTP will be sent to Carol. As soon as we end up, we turn off the call, so we decided that we listen enough. Of course, a buy will be sent, detected by or intercepted by the B2B entities module, and the flow will disappear. So the call will remain in the exactly initially state that it had started. Another interesting scenario that we are doing using the media exchange, so not the media forking, is playing music on hold. So we have a call again between Alice and Bob. RTP flows as normal. And Alice, at a certain point of the call, he wants to put Bob on hold. So Alice will press the on hold call. This will result in sending a re-invite with a new SDP saying, hey, put Bob on hold. We will intercept this re-invite and start a new call to the media server saying, hey, play me a music on hold file and send it to B's SDP. So notice that Alice put the call on hold, but we provide Bob's SDP. This is exactly why we need the dialog module. That's because we already have the SDPs saved in the dialog module. Of course, we could have done something like challenge Bob, hey, Bob, give me another SDP, but that requires a bit more complexity. And I'm not sure whether, because most of the time, to be honest, I've never seen the SDP changed unless the service changes on the other side. So Bob will probably remain in the call, so nothing will change from the SDP perspective. So we'll simply fetch the SDP of Bob and send the call to start a new call to the media server. The media server will send us an SDP, so it will send a 200 OK with a new SDP that we will forward to Bob in a re-invite containing the media server SDP. So notice that how we migrated or how we mixed the SDP from the blue call to the SDP of the green call in a re-invite. As soon as the re-invite ends up here, the RTP will stop flowing. That's because Alice will no longer send anything because he's on hold. Therefore, the RTP will flow. So basically, the media server will start playing back RTP music on hold to Bob. When the call is resumed, so now the state is as it is. So we have a call here. We have no RTP between Alice and Bob. That's because Alice is on hold and Bob is receiving RTP from the media server started by this call. But at a certain point, Alice wants to resume the call. So he will send a re-invite with a plain SDP, so no longer on hold SDP, sent to OpenSIPS. Again, we intercept that call. We will send the byte to the media server. This RTP flow will disappear. And we will simply forward the SDP that we receive from Alice. We'll send it in the re-invite to Bob. This will establish the RTP between these two endpoints. So Alice will continue talking to Bob. The media server has already closed the call. So basically this call will terminate. We will end up in the exact same state that we started. So again, a simply proxied call between Alice and Bob. So the media server no longer needs to be involved in the call. Therefore, this allows us to scale our media servers as much as possible. Another interesting call scenario is call whisper. Again, same scenario. We have Carol that Carol wants to say something to Alice. Let's say we're in a call center scenario, and the admin notices an agent needs some help. He wants to help him out by telling him something. So he will send a call saying, "Hey, I want to whisper something to Alice." This call will have Carol's SDP. What we will do is trigger a re-invite with Carol's SDP to Alice. Of course, we will also have to re-invite Bob with Alice's SDP, but on hold. That's because we don't want Bob to send anything else to Alice, because Alice needs to talk to Carol. So this RTP flow will disappear, right? But Alice will start talking to Carol using its own RTP session. We have this state. Carol has said everything that needed to be said to Alice. We want to terminate this. What will happen is that Carol will send a bye because he decided that everything was terminated. A re-invite will be sent to Alice with Bob SDP, right? So no longer with Carol's. Again, a re-invite will be sent to Bob. That's because we want Bob to talk to A, so A is no longer on hold. As soon as the bye is received, of course, the RTP terminates here. And due to the two re-invites, it will start flow from Alice to Bob. Therefore, this call has terminated. And again, we ended up in the same state that we were before. And finally, and probably the most interesting scenario, is the barge in call. So we have a call between Alice and Bob that has started as a regular call, no media server involved, it's just OpenSIPS and the dialog module. And Carol, Carol wants to talk to both of them. So basically, he wants to barge in a call and basically discuss with both Alice and Bob. What he will do, he will say, hey, I want a conference with Alice and Bob, and here's my SDP. This is where I want to talk in the conference. What OpenSIPS will do, it will send the call to the media server and ask the media server to start the conference. So again, so Carol will end up talking to the media server. However, in OpenSIPS, we detect this scenario and we will trigger a call saying, hey, we will start the call with A's SDP. We will start the call within the same conference to the media server. So this light blue call is a completely different call. We'll provide A's SDP. Whenever we get the 200 OK, we will send it in a re-invite to Alice. So we will say, hey, Alice, now send SDP to conf A. What will happen is that Alice will talk to the media server. And then what about Bob? So remember that I was going to tell you a case where Bob doesn't need to be put on hold. Well, this is exactly the same scenario because we don't want to put Bob on hold. We want Bob to be involved in a conference. Therefore, we will start a third call to the media server saying, hey, I want Bob in this conference as well. His SDP. We'll get back a new call, a new 200 OK with Bob SDP, with the conference SDP associated to Bob's call, and we will send a re-invite to Bob saying, "Hey, you should be able to talk in this conference using this SDP." So Bob, what will Bob do? It will start its call to the media server. So basically, all three entities end up in the very same conference in the media server. So all of them will be able to talk to each other. Whenever Carol wants to terminate, I didn't animate this anymore, but what will happen? It will send an end. The media server will probably send an end or a bye, and OpenSIPS will close these two dialogs and, of course, send two re-invites to Alice, ending up in the very same state as this one. So basically, the media server is released, and the call will continue as it was running up until now.
But in this last case of the call barging, when you start conferencing, the media server in this case will be asterisk or free switch or someone that is able to do conferencing.
Definitely somebody that has conferencing capabilities. Otherwise,
okay. And another question for the case before the whispering. You usually, at least with B2B, whispering, you whisper to the agent, but the agent at the same time is speaking with the end customer, let's say. So you may want to change a little bit the whispering procedure So you put actually a conferencing also in this case, and but
probably mute.
You mute in the other direction.
That is completely correct, but yeah, well, this is let's say just a way of how the module works. Basically, you can anyway you can resume everything to this scenario, which is the most complex, and you can have your conference and all these calls can tune, or you can do it from outside. You can tune each leg, who's allowed to talk to who, and so forth. So of course you can do that as well, but the main power of this scenario is that you can always go back to the initial state. So you can always release the media server, so you won't remain stuck in that conference, right? So this is basically what we wanted. Not sure if I think there is a couple of minutes to also make a demo. So let me quickly, it's not a long demo. Let me quickly show you what I wanted to. So I will show my entire screen. There we go. Okay. So what I will do now is start a call to Bob. Okay, sir. Hello? Okay, so can we see? And now I put this call on hold. Something happened. Okay, the call terminated. Let me try again, because it wasn't supposed to do that. It should have played RTP. Let me see. Oh, okay, I know what happened. Let me see. Okay, so what happened is that I used the script from the previous demo, and it prompts me for the pin code, so *1234. Let me put it on hold. Okay. So now you can probably hear the music on hold. Let's see what happened. So again, we have these two calls. The first call was from Alice to Bob, sorry. And this is when Alice put the call on hold. Let's see. So we have the send only marker. And what we are sending to Bob, so is this SDP, which, as you can see, is FreeSwitch's SDP. We get this SDP from the second call that we start from OpenSIPS to FreeSwitch moh@freeswitch.training.org. Okay, so now Alice is on hold. I will resume. Hello? Okay, another feature that I want to show you is that you can trigger commands from outside. So I'm using Media Exchange from call.
There's a lot of echo going on for some reason. Maybe you have some phone.
Yeah, I'm echoing with the phone. I just need to prove something, and I will turn it off. So what I want is to make an announcement in this call. So okay. That's it. Thank you very much, guys. I hope you enjoyed my demo. That's what I wanted to prove. And yeah, if there are any questions you would like to ask, let me know.
There is guys on YouTube asking to see some code examples. How does CFG look like?
Sure. Okay. Sorry, show.
One more question.
So this is all I've done for this to work. So basically, what I've done was to load the two modules, and when I get an invite that is that
we
has
can't
audio.
see
your screen, Razvan.
we can't see
sorry.
anything.
Sorry about that. I stopped the presentation.
How about SRTP, Razvan?
Are you seeing now?
Yep.
Looks
So
good.
this is all I had. This is all you need. So basically, you load these two modules, and you handle this whenever you get an invite. If it's on hold, you decide who to play back. Here, I decide who to play back the music and simply call these functions. Hey, say play me, or start a call to this URI for this leg within the call. And whenever the call is resumed, just media terminate, so we can resume the two entities. That's it. I want to. So this is for music on hold. For the announcement, you really don't need to do anything.
Very elegant.
You really don't need to do anything else. Just call the MI function, the MI call that I had. It will say that there's no longer a dialogue here because I already turned it off. But that's it.
Time to write a new book, Giovanni.
Yeah. You have some resources here, and you will also. Okay, I don't think you see my screen now. Let me show it. Here, I already a few days ago I already sent you a Git repository with the configuration file. You will have this this config file as well in this repository. So simply open it and play with it. You will be able to do what exactly what I've done until now. Of course, you will probably have a free switch and a free switch that will answer to that those. Extensions that I used, for example, MOH or the announcement extension, but yeah, that's not that hard to configure. You can also find a few more details about the Media Exchange in the blog I've written a while back, so give it a try. Are there any other questions?
Yeah, Razvan, I'm just curious. How does this work with SIP session timers? Like in the example where Alice was put Bob on hold. What happens if Alice's phone sends a re-invite, like a session timer? Because you can't really forward that to Bob, right? Because you'll kill the whole music.
Yes, basically that will be forwarded to the media server. So basically, it will move from one leg to the other.
It will the back-to-back level, right? Or
yes.
Okay, good. So it's transparent. It's not available in the script, or
it is available in the script. You will basically, because the re-invite that comes in the original dialog, so you'll see it at the script level. So you'll have to call a special function that is media handle in dialog request or something like that.
Oh, okay. So there's a special function for it. Okay.
Yes, that will absorb it and send it on the B2B leg.
Okay, thank you.
I think there was another question. What happens with this RTP?
Yes, when I was asking.
Basically, the SRTP, the same SDP that was provided at the initial, will be sent to free switch. Therefore, free or the media server, let's say, and the media server will basically reestablish another SRTP session with the endpoint. So they will continue to discuss to each other. Not sure. Actually, the session will be renegotiated when the session is resumed through those two re-invites.
Okay.
To be honest, I've never tested that, but yeah, let's give it a try and see what happens. Why not?
I want to add something. Free switch is the perfect choice for doing, for example, a music on hold server, media server, because it has a spatial mechanism. So actually, the music on hold file or files that are inside one directory are read in a round robin fashion, but one only time. So there is a special module, is an internal service of FreeSwitch that just read the media file, and then it broadcasts to all calls. So if you have 10,000 calls that comes to the music on hold on FreeSwitch, it will be one of the cases where FreeSwitch is very, very, very light. Because it will just broadcast the same RTP stream to all the calls. It will not read multiple time the same media file.
I have a small question, Razvan. In one of the slides, you talked about call whispering in a way that you decided to implement it. For example, play media to the caller, right? So my question is as follows. Given that I've already looked on a couple of sites, such as Twilio and Vonage, and by call whispering, they understand playing media to the agent. So it has information about who is calling, maybe what kind of campaign they rang, the number 4 or whatever. So my question is this call whispering scenario that you talked about in the slides built into the module, or do you have like a flexible way of playing media to either caller or callee and implement whispering just the way you want it to?
Yes, so basically what I showed you earlier, like the announcement that I made is very flexible because you can use it in the, you basically trigger it over MI, and you can choose whoever, either caller or callee, you want to play it to. And basically this is the input. You give it the call ID, the leg that it has to be played to, and the destination of the URI. So basically the extension that is going to
Perfect.
to
So
talk.
it's very flexible and low level. You can build whatever scenarios you want with it. Awesome.
Exactly. Are there any other questions?
I got one more, I guess. When trying to listen to a user agent, you basically just have to kind of guesstimate the codecs that you have to use, or is there any way to fetch them actually to know?
So it depends. When you call in, so when the call starts from a phone or from a user agent, when we get the invite, we know the codecs that are that are used. So we narrow down to the codecs that are supported by both caller and the third party. If there's no codec available, you will probably get 488. Yeah, 488. So this is when the call dials in. When we dial out, basically we present whatever codecs were sent by the either caller or callee. So we just send the codecs that were that we had in the SDP. So even either the caller accepts them or just drops the call because he's not able to use them.
Okay, gotcha.
So if I got it correctly, you use the dialog module to keep track of the original SDP of each leg of the calls. And then you send a command so those original SDPs are put into the rainbyte and you come back to the original situation.
Correct.
This infrastructure, so this keeping of the original legs SDP into the dialog module and the command to repristinate through rainbyte those original SDPs are usable also outside your scenarios.
Yes, so actually I was just using them because they were already in there. For example, for doing pinging reinvites, you need the SDPs that were initially saved. So you already have the SDPs, you just send them as a dialog reinvites one to each of the party. So we already have the SDPs, I think, since, I don't know, Vlad, when did you wrote that?
I don't remember. I'm sorry.
Yeah, it's probably 2.1 or something like that.
Yeah.
So yeah, we have them up until now. We only had them when reinvite was engaged. What I modified is just always store them.
That's perfect. Because yeah, I use the pinging reinvites particularly for WebRTC. So if they change,
you will get it.
Yeah, but the possibility to use it in a arbitrary way, that's very useful. For example, if like we were talking yesterday, if FreeSwitch do something exaggerate into managing music on hold here, there, etc., always you can repristinate the original flow.
Yeah,
and
you're
back
just
in a controlled situation. That's perfect.
Yep.
Good.
Is there time for one more question from Jeff Pyle on YouTube, or
yes,
are we
sure.
running out of time? So Jeff says,
okay, go ahead.
Could the barging example be integrated with a back-to-back shared call appearance module to allow barging shared call appearance functionality?
I really can't answer this. Sorry. I will check it out and let you know, because I need to. I really haven't used that module, so I really don't know what it does. Sorry about that.
Do we have any other questions?
Yeah, I think my time's up. Thank you guys for paying attention. Hopefully, I hope you liked my demo, and yeah, see you later during the party.
Good job.
Thanks, Razvan.
Well done.